Today I am explaining about the types of registers in digital electronics. In registers, data may be moved in and out serially or parallelly, depending upon this. Shift registers may be classified as serial in, serial out shift register, serial in, parallel out shift register, parallel in, serial out shift register, and parallel in, parallel out shift register. Serial in, serial out shift register. In this case, all the bits are loaded in and shifted out is bit by bit or serially. It may be noted that each bit is moved in and or out for each clock pulse. So data shifting may be from right to left or left to right. If the data is shifted from left to right, the shift register is called a shift right register. If the data is shifted from right to left, then the shift register is called a shift left register. A serial in, serial out register introduces time delay in data transmission. The IC7491 is an example for serial in, serial out shift register. Next, serial in, parallel out shift register. In this case, all the bits are loaded in is bit by bit and shifted out simultaneously. That is, at a time, all the data bits are taken out. Next, parallel in, serial out shift register. In this case, the data is loaded simultaneously. That is, all the bits of a word are loaded in a single clock pulse, whereas the data shifted out is bit by bit or serially. The parallel in, serial out shift register is very useful in transferring data from a high speed device to a low speed device. Similarly, the serial in, parallel out shift register arrangement can transfer data from a low speed device to a high speed device. The IC74165 is an example for parallel in, serial out shift register. Serial in, serial out shift register. In the serial in, serial out shift register, data is input serially until it reaches the output. Next, need for register. The two basic functional characteristics of a register are temporary storage, shifting capability. Temporary storage. Registers are commonly used for the temporary storage of data within a digital system. The storage capability of a register is one of its two basic functional characteristics and makes it an important type of memory device. The concept of storing the binary information either 0 or 1 in a flip flop. A binary 1 is applied to the input and a clock pulse is applied that stores the 1 by setting the flip flop. When the 1 on the input is removed, the flip flop remains in the set state, thereby storing the 1 bit. The same procedure is applied to the storage of 0 bit. Next is shifting capacity. The shifting capability of a register permits the movement of data from stage to stage within the register or into or out of the register upon application of clock pulse. The types of data movement in shift register operation. The 4-bit register and the indicate the direction and types of data movement in above PPT. Next time I explain about the working of 4-bit shift right register. So it's a black diagram of a 4-bit shift register as shown in above PPT. The shift register that shift the data by 1 bit to the right is known as a shift right register. The functional black diagram of the 4-bit shift register shown in above PPT. So this contains 4 different D flip flop and D0 to D3 and Q0 to Q3 are the 4 different outputs, and here input D and clock signals as shown in above figure. So here 4-bit shift right register using a positive edge triggered D flip flops It may be noted that the shift right register is an example for a serial in serial out shift register with the four stages, that is 4 flip-flops. The register can store up to 4 bits of data. Serial data is applied at the D0 input of the first flip-flop through the input DN. The Q0 output of the first flip-flop is connected to the D1 input of the second flip-flop. The Q1 output of the second flip-flop is connected to the D2 input of the third flip-flop, and the Q2 output of the third flip-flop is connected to the D3 input of the fourth flip-flop. The data is outputted from the Q3 terminal of the last flip-flop. When serial data is transferred into a register, each new bit is clocked into the first flip-flop at the positive going edge of each clock pulse. The bit that was previously stored by the first flip-flop is transferred to the second flip-flop, is transferred to the third flip-flop, and so on. The bit that was stored by the last flip-flop is shifted out. In operation, you can take one example that is it is 4-bit shift right register. So take Q0, Q1, Q2, Q3 and clock 0, 1, 2, 3, 4. And here example is 1, 1, 0, 1. So that is first LSB bit 1, 0, 1, 1. So first during the initial condition all are 0, 0, 0, 0. And next after applying a first clock pulse, that is 1, next 1, 1, 1. Next again second, during the second clock pulse 0, next 1, next 1, next 1. Next during the third clock pulse 1, 0, 1, 1. During the fourth clock pulse 1, 1, 0, 1. So here operation, in order to understand the working of the shift right register, let us assume that we wants to store the data 1101 in the register. This data will be applied at the input D0 of the first flip-flop, one bit after another. First we shall apply the LSB, that means 1 to the D0. At the positive going edge of the first clock pulse, the LSB bit 1 is sent to the output of the first flip-flop, and hence Q naught becomes 1. Therefore Q naught is equal to 1. Q1 is equal to 0, Q2 is equal to 0, Q3 is equal to 0. Or Q is equal to Q0, Q1, Q2, Q3 is equal to 1, 0, 0, 0 after the first clock pulse. The next data bit to be stored is 0. This is now applied at D0. At the positive going edge of the second clock pulse, the value present at Q0 is sent to the output of the second flip-flop and store in it the data bit present at D0 is stored in the first flip-flop. Therefore Q0 is equal to 0, Q1 is equal to 1, Q2 is equal to 0, Q3 is equal to 0. Okay. And the next bit is 1. So here Q0 is equal to 1 and Q1 is equal to 0, Q2 is equal to 1 and Q3 is equal to 0. Therefore Q is equal to Q0, Q1, Q2, Q3 is equal to 1, 0, 1, 0. 10101010, yes. And next, take fourth clock pulse, that is bit is 1, so Q0 is equal to 1, Q1 is equal to 1, and Q2 is equal to 0, and Q3 is equal to 1. So 1 1 0 1, Q4, sorry, Q. So here the bit have moved to right by 1 bit position. The same continues till all the data bits are stored in the flip-flop. In above PPT, show time pulses output operation of the shift right register. So here QA, QB, QC, QD and serial output is QD. Initial value after first clock pulse, after second clock pulse, and after third clock pulse, and after fourth clock pulse. You can shift right 1 by 1 from LSB to LSB. So first initial condition all 0 0 0 zeros, and after first clock pulse that 0 0 0 0, and after second clock pulse that is 1 1 1 0. Next 0 1 1 0, and next 1 1 0 1, and finally 1 1 0. And next second method, let D input is equal to 1 and Q is equal to 0 0 0 0. All data inputs except the one on the left are zeros. The first positive clock edge sets the left flip-flop and the stored word becomes Q is equal to 1 0 0 0. With the appearance of this word D0 and D1 are ones, the second positive clock edge gives 1 1 0 0, and the third clock pulse gives 0 1 1 0, and the fourth one is gives 1 0 1 1. Next explain about the 4-bit shift left register. The shift register that shift the data by 1 bit to the left is known as the shift left register. The logic diagram of the 4-bit shift left register as shown in above PPT. A 4-bit shift left register using positive edge trigger, it is D flip-flops. It is also an example for serial in serial out shift register. Next, with the four stages, that is four flip flops. The register can store up to 4 bits of data. Serial data is applied at the D3 input of the last flip flop through the input DN. The Q3 output of the last flip flop is connected to the D2 input of the third flip flop. Q2 output of the third flip flop is connected to the DN input of the second flip flop, and the Q1 output of the second flip flop is connected to the D0 input of the first flip flop. The data is outputted from the Q0 terminal of the last flip flop. So here again 4 different D flip flops are arranged. In this register, from D3 to D1, D0 you can shifted the data. That means MSB bit to LSB bit. So here D3 is the input and its output is given to the D2, and the D2 output is given to the D1, and the D1 is output is given to D0. So now operation and 4 outputs Q0, Q1, Q2 and Q4, and for fourth output flip flop D3, its output is connected first to. In order to understand the working of the shift left register, let us assume that we want to store the data, that is say 1101 in the register. This data will be applied at the input of the last flip flop, one bit after another. First we shall apply the MSB bit 1 to the D3. At the positive going edge of the first clock pulse, the MSB bit 1 sent to the output of the last flip flop, and hence Q3 becomes 1. Therefore Q is equal to 0, Q1 is equal to 0, Q2 is 0 and Q3 is equal to 1, or Q is equal to Q0, Q1, Q2, Q3, that is 0, 0, 0, 1 after the first clock pulse. And Q is equal to Q0, Q1, Q2, Q3 is equal to 0, 0, 0, 1 after the first clock pulse. The next data bit to be stored is 1. This is now applied at D3 at the positive going edge of the second clock pulse. The value present at Q3 is sent to the output of the third flip flop and stored in it. The data bit present at D3 is stored in the last flip flop. Therefore Q0 is equal to 0, Q1 is equal to 0, Q2 is equal to 1 and Q3 is equal to 1, or Q is equal to Q0, Q1, Q2, Q3 is equal to 0, 0, 1, 1 after the second clock pulse. Thus the bits have moved to left by 1 bit position. The same continues till all the data bits are stored in the flip-flop. So here take a initial condition, that is D, put to the D3. It is a 1, 1, 0, 1 LSB bit, and here Q3, Q2, Q1, Q0 and clock pulse. It is 0, 1, 2, 3, 4. So first from MSB to LSB in a left register. So that is take a table form and solve the problem. So here this is 1 and this one is 1 and this is 1 and this is 1. The next second clock pulse, again 1, 1, again 1. During the third clock pulse, 0, 0. Next fourth clock pulse is 1. So first 0, 0, 0.